Hello friends, good morning, good afternoon. In the last lecture, we have discussed resultant of parallel force system and with the help of some examples, we have discussed how to use the concept of moment as well as the Varignon's theorem. Now in this lecture, we'll go to the next system of forces that is called resultant of non-concurrent force systems. Now first let us see what are the steps which we are going to follow. First step is to calculate the summation of x. Second step is to calculate the summation of y. Then to find out the magnitude of the resultant and then find out the direction of the resultant. So up to this, the steps which we have used for a concurrent force system and the this resultant of non-concurrent forces, it is same. Now only one additional step, we'll have to locate the position of a resultant on the body with respect to the geometry of that particular body using Varignon's theorem and using the concept of moment. And this Varignon's theorem, its application and concept of moment already we have discussed in when we have studied the resultant of parallel force system, that is summation of moment of all forces will be equal to moment of their resultant about the same point, where this r into a is the distance between the point and the line of action of the resultant. Okay, so these are the steps which we are going to follow when we calculate the resultant of non-concurrent forces. Let us take a very simple example. Determine the magnitude and direction and the position of resultant with respect to O. So this is a plate. And on this plate, this force 15 kilonewton is acting. Its inclination with horizontal is 60. Second is 20 kilonewton. Inclination with horizontal is 30. Is 10 kilonewton acting to the right horizontally, and this 20 kilonewton at O acting downwards, vertically downwards. So this is the force system. So very first step, you resolve this force inclined forces. So this I will resolve. You see components 20 sine 30 and 20 cos 30. Similarly this I will resolve 15 sine 30 vertical component and 15 cos 60 horizontal component. You see the force is acting like this, and that's why vertical component will be upwards and horizontal component will be to the left. Now this is a horizontal force, no need to resolve. This is a vertical force, no need to resolve. So show all these forces as it is. So this system, now this and this, they are same, only we have shown the components of these inclined forces. Now let us take summation of fx. So summation of fx will be 20 cos 30. It is acting to the right and that's why it is positive. Next horizontal force minus 15 cos 60 to the left and that's why it is negative. Then this 10, it is acting to the right and that's why it is positive. So total summation of fx is 19.82 kilonewton. Now let us take summation of y, that is equal to 20 sine 30 upward and that's why it is positive, 15 sine 60 upward and that's why it is positive, this 20 kilonewton downwards and that's why it is negative. So if you calculate this total, you will get summation of y is 3 kilonewton, and hence you will get r under root of fx square plus fy square. If you substitute fx and fy, r equals to under root of 19.82 square plus 3 square equal to the magnitude of the resultant is 20.04 kilonewton. Similarly, you can find out the direction, that is theta, tan inverse summation of fy by fx. Tan inverse 3 divided by 19.82 equal to 8.6. 0 degree, and resultant is in first quadrant because fx is positive and fy both are positive. Now, how to calculate the position of the resultant with respect to O using Varignon's theorem? So we have taken, that is resultant already we have calculated. So summation of moment about this point O. We'll take the moment of forces about point O. So how we will take, you see, let us start with this force 17.82 acting to the right. Okay, its perpendicular distance, vertical distance is 2 meter. So 17.32 into 2 minus, because this will produce clockwise moment about O, plus 10. This 10, this 10, this 10 vertical component, this vertical component. So this vertical component, how it will produce the moment about point O? It will produce in anti-clockwise. That's why plus 10 into perpendicular distance is 2, plus this 7.5 horizontal component, how it will produce the moment, how it will rotate clockwise. Sorry, 7.5 it will produce anti-clockwise. So plus 7.5 into 2. Now this 10, it is passing through O, and that's why moment is 0. Similarly, this vertical component, that is 13 kilonewton, this is also passing through O, and that's why the moment is 0. So here the net moment, it comes 0.36 kilonewton meter is positive, that's why it is anti-clockwise. We know the resultant R 20.04, so R into A equals to 0.36 into A. What is A? A is a perpendicular distance from the point of rotation up to the line of action of that particular resultant which we are assuming, and hence if you calculate this A, you will find the resultant lies at a distance of 0.01796 meter from point O. Okay. Then next is, you see, this resultant lies in the first quadrant. This I have shown, and the perpendicular distance which we have calculated 0.01795 meter, that also I have shown. So this is the finally we got the resultant of this entire system of forces. So this resultant, if you see about point O, its sense of rotation is anti-clockwise, and that's why resultant will produce anti-clockwise movement about point O. Okay, so this system, this entire system is replaced by the single force, and if you want to transfer it to the origin, then what you will do, you can take the moment of this force. So moment will be 20.04 multiplied by lever arm 0.01795. You will get the couple, that is the moment, will be equal to 0.36 kilonewton meter, which will be acting anti-clockwise, and the same force we have transferred to this point. So this is this is a given force system. This is equivalent force system to this, and this is equivalent force couple system to this. So effect produced on a body by this system, by this system, and by this system, they are same. Is it okay? So this is a this way you can solve the problems on non-concurrent force systems. Okay, let us take next example. Same, that is, I will take let us consider the this a rectangular plate is acted upon by the force and couple shown. The system is to be replaced with a single equivalent force for alpha equals to 40 degrees given. Specify the magnitude and the line of action of the equivalent force. So here now first you resolve these inclined forces, this alpha and this alpha, they are same 40 degrees. Now you can first resolve these forces. You see this force I will resolve into two components. Vertical component will be, this alpha is given 40 degrees, so with horizontal how much it will be, 50 degrees. So this you can take that is 13.5 sine 50 will come 10.34. If you take cos, it will be 8.67 Newton. This is a vertically downward force, no need to resolve. This force, similarly, if you resolve, you will get two components is acting towards the point. So components will be horizontal will be to the left, vertical will be downwards. That is what I have shown. And these are the components 10.34 and 8.67 Newton. So this is the system now of forces after resolution. If you take total summation of x, now you do it, it will be 0, and summation of y will be equals to minus 45 Newton. So you can find out the resultant R using this equation 45 Newton. It will be downwards. Why? Because x is 0. When summation of horizontal forces is 0, resultant is vertical. It may be upward, it may be downward. We got minus sign, and that's why the resultant is downwards. Now to find out the position of resultant with respect to A, using Barigno's theorem, let us take the moment of all forces at point A, all these forces at point A, and take the moment of their resultant about the same point. So MA will be equal to this 45. Sense of rotation is clockwise. That's why minus 45 into the distance is 0.4. Next, minus 10.34. This force like this. Sense of rotation is clockwise. That's why minus 10.34 into 0.4. Minus 8.67. This force. You see this force. 8.67. How it will produce movement? About a clockwise, and that's why minus 8.67 into 0.25. This distance, vertical distance, is 0.25 equal to, now you will find this force, the moment is 0. Why? It is passing through the same point. Okay, and that's why it is 0. So total moment it comes minus 24.30 Newton meter. Minus means clockwise. Now you apply the same equation, R into A equals to minus 24.30 equal to 24.30 into 45. You will get the distance, that is 0.54 meter from point A. This is the position of resultant. So this way, you see, I have shown from point A, resultant is vertically downwards, and it lies at a distance of 0.54 meter. So total system we have replaced by the equivalent force system. Let us take this last problem. Two forces acting as shown in figure. Determine the single equivalent force coupled system. First you resolve these forces. This is the force system. You resolve this into two components. 20 sine 25 and 20 cos 25. This you can resolve 30 cos 30 and 30 sine 30. Components already I have explained. So what is this? This is this point. The coordinates are given. X coordinate is 3, y coordinate is 4. For this point, x coordinate is 5 and y coordinate is 2. Okay. So you can easily take now the moments about origin. First you calculate the summation of fx. This will be plus 20 cos 25. This will be minus 30 cos 30. You will get fx equal to minus 7.854 Newton, and summation of Fy, this plus this, both are upward, and it comes to 23.45 Newton. Magnitude of resultant using this equation, if you find out, you will get equal to 24.73 Newton, and theta will be equal to, if you substitute Fy and Fx, you will get 71.48, and resultant is in second quadrant because Fx is negative and Fy is positive upward. So resultant will be somewhere here. Resultant will be somewhere here. Okay. Now, to find out the position of a resultant with respect to O using Varignon's theorem, same equation we'll have to apply. Let us take the moment at this point. So, this 20 sine 25, 20 sine 25, if you extend, x coordinate is how much? 3. So, 20 sine 25 into 3, and this will produce anti-clockwise movement about O, and that's why it is positive. Minus this 20 cos 25 about origin of the system, it will produce clockwise movement. So 20 cos 25, this line of action, if you extend, y coordinate is 4, that's why multiplied by 4, plus 30 cos 30, this 30 cos 30, if you extend, it will give anti-clockwise movement, 30 cos 30 about point O. If you extend it like this up to this point, our sense of rotation will be anti-clockwise, and y coordinate is 2, and that's why multiplied by 2, plus this 30 sine 30 also will give the anti-clockwise movement, and x coordinate is 5, and that's why this distance 5, so we'll have to multiply it by 5. So total moment will be 79.811 Newton meter, and positive, and hence it is anti-clockwise. So use the same equation, R into A equals to 79.811 Newton meter, hence you will get A equals to 79.811 divided by magnitude of the resultant is 24.73. So the distance is 3.22 meter. So from origin, the resultant lies at a distance of 3.22 meter. So this is about numerical examples on resultant of non-concurrent or general force system. I hope you understand. You make a practice and try to solve some additional problems on general force system. So with this, I conclude unit number 1, and in the next lecture, I will start unit number 2, that is equilibrium. Okay, thank you very much.